Hi guys, welcome to another video. So I want us to pay attention to this Slinky here. Now obviously you know the Slinky generates a longitudinal wave, and I want us to focus on this 550 millimeters. This here is not the wavelength, and in this video I'm going to explain to you why 550 millimeters is not the wavelength. So the first question says, define the term longitudinal wave. So a longitudinal wave is a wave where the particles vibrate parallel. So this here is a keyword. The particles vibrate parallel to the wave motion. So if you consider the particles, or let's consider a particle, suppose this particle here by x, you'll see that this particle vibrates along the x-axis, back and forth. It vibrates back and forth. So this is how the particle behaves. It moves back and forth, hence it's vibrating. And the wave itself, or the wave propagation, is from left to right. So when the motion of the particle is parallel to the motion of the wave itself, we say it's a longitudinal wave. So 3.2, two learners used a Slinky spring and produced a wave pattern as shown in the sketch. 3.2.1, points x and y represent regions where the coils are spread apart. So you can see here, the coils are spread apart, thus maximizing the distance between the coils. What is the name given to such points? Now, regions where the coils are spread apart, creating a gap between the coils, is what we call rarefactions. And the next question says, points O, P, and Q represents regions where the coils are pressed together. What comes to mind? Compression in small amounts of space. What is the name given to such points? So where the coils are compacted, like in these regions, you can see there are compressions. So the name for such regions is compression. Compression. The next question says, determine the wavelength of the wave in meters. This is very important. I'm just going to underline it in meters by using the sketch. So recall earlier on I said 550 millimeters is not the wavelength. Let me explain why. Remember the definition of a wavelength. The definition of the wavelength is the distance between two consecutive points. Consecutive just means points that are following each other. Two consecutive points that are in phase. Now if you consider these two points, they both fall under compression, so it is points in phase, but these are not consecutive. Remember, consecutive means points that are following each other. So a point like this at point P, that would be consecutive points. O and P make up consecutive points. So this distance here would be your wavelength. And similarly, P and Q are consecutive points that are in phase, because P and Q are of course compressions, so they are points in phase. So this distance here is another wavelength. So 550 millimeters makes up two wavelengths, 1, 2. So mathematically you could write two wavelengths is equals to 550 millimeters. You can divide throughout by 2. 2 and 2 cancels here, therefore the wavelength is equals to 275 millimeters. But recall earlier on they wanted the answer in meters. So you know, in a meter there's 1,000 millimeters, so you just divide by 1,000. And this gives us 0.275 meters. And the last question says, calculate the period of the wave if the velocity is 9 meters per second. So let's list all the information we have and all the information we don't have. So period is something we don't have, it's what we're looking for. And then the velocity is given to us as 9 meters per second. We also have the wavelength, which we just found to be 0.275 meters. Now guys, genuine question, is there a formula that we can apply that can relate these three parameters? Is there any formula that you can think of that relates the period, velocity, and the wavelength? If your answer is the wave speed equation, you are correct. So you know the wave speed equation can be written as the speed of the wave is equals to the wavelength divided by the period. So this implies that the velocity is 9 meters per second is equals to the wavelength, which is 0.275 all over the period. Therefore, the period should be equals to, if you rearrange the equation and solve for t, you'll get 0.275 divided by 9, and this gives us 0.031 seconds, correct to 3 decimal places. Thank you guys for tuning in. Please do me a favor, consider subscribing and liking the video. If you have any questions, please let me know in the comment section. I will do my best to answer you. See you guys in the next one.